In the second part of 6.1, we will talk about compound interest. So if P dollars are deposited in an account paying an annual interest rate of R dollars, compounded or paid N times per year, then after T years, the account will contain A amount of dollars. So this is the formula. A equals to P times the quantity 1 plus R over N raised to the NT power. Now A is the amount of money in the account after T years. P is the principal or the initial investment. R is a rate of interest. Remember, R has to be in decimals. N is the number of times the number of times per year that interest gets compounded, and T is equal to the number of years. Okay, so here's what this is saying. This is saying that you invest some kind of you invest some amount of money in the bank account, and let's say the interest is compounded daily. So what it means is that every single day the interest on your principal amount gets calculated, that gets added to your principal amount, and then the next day the interest that is calculated is going to be on that based on that new amount. So your amount is always growing. So we're going to talk about the values of n, okay? Because we know r is the interest rate, t is time, p is the principal amount. The only thing we really have to worry about is the value of n. So let's talk about the values of n. Okay, so if n is just how many times per year does interest get compounded? So if we're compounding interest daily, then n is going to be 365 because there are 365 days in a year. Therefore, the interest will get compounded every day. In other words, 365 times. Okay, let's say that we want to compound interest weekly. So how many weeks are there in a year? There are 52 weeks. So the interest gets compounded every week, which means in 1 year, it'll get compounded 52 times. Okay, what about monthly? So if the interest is compounded every month, how many times will it get compounded by the end of the year? Well, 12 times because there are 12 months in a year. All right, what about semi-annually? So semi-annually, semi means two. So semi-annually means it's going to get compounded twice a year. So the value of n equals to 2. And then annually, it means that you only compound interest once a year. So n is going to equal to 1. So these are the values of n. So here's an example. If $18,000 is deposited into a bank account at an interest rate of 4%, how much money will be in the account after 10 years if the interest is compounded daily? So once again, for daily, the value of n is going to be 365 because there are 365 days in a year. So the amount that's in the account is going to be the principal amount, which is 18,000. That's how much money is initially deposited, times 1 plus R. Now it's an interest rate of 4%, which is 0.04. So 1 plus 0.04 divided by n, so that's 365 because interest gets compounded 365 days times a year. And then that's raised to the power of n times t. So now what is n? N is equal to 365 and t is equal to 10 because we want to look at the amount in the account after 10 years. So now it's just a matter of plugging this into a calculator. If you have a scientific calculator, you can plug things in exactly the way it looks. So we got 18,000 times 1 plus R, which is 0.04, divided by 365. And then that's raised to the power of 365 times 10, which is 3650. Now, if you want to do this part by part, you can do that as well. Then do the order of operations. So do the parentheses first, then do the exponent, then multiply. You can do it that way too. But I'm getting 26852.27. Now, what I recommend is that you do this on your own. Plug this in to make sure that what you're getting and what I'm getting is matching, just to make sure that you know how to put this into a calculator correctly. And oftentimes, you'll have to multiply the 365 times 10 to get 3650 when you put this into a calculator. So that's the only thing you have to do ahead of time, but everything else you can plug in the way it looks. If not, you have to do it part by part. So first just do 0.04 divided by 365, then add 1, then raise that to the power of 3650, and then multiply it by 18,000. Okay, so figure out whatever's going to work best for your calculator. Now, if it gets compounded weekly, that means n equals to 52 because we have 52 weeks in a year. So we got a equals to 18,000 times 1 plus r, which is 0.04. But instead of 365, we now have 52 because the interest is not getting compounded every day. It's getting compounded every week. So there are 52 weeks in a year, which means it gets compounded 52 times, raised to the power of 365 times 10, which is 3650. Why is it times 10? Because it's after 10 years, so t is 10. All right, so let's go ahead and figure that out. So we're gonna change the values of n to, oh, you know what? Actually, I take it back. So n, we change that from 365 to 52, so this should actually be 52 times 10. So I apologize for that. It should be 52 times 10, which is going to be 520. And then I'm getting my answer as 26,848.72. And notice that we get a little bit more money if it's getting compounded daily because your interest is getting compounded more often. Okay, let's do one more, and the last two we'll do in class. What about monthly? So for monthly, we have A equals to 18,000, that's your principal amount, times 1 plus the interest rate, which is 0.04. Monthly, it means we're going to have n equals 12. There are 12 months in a year, so interest gets compounded 12 times, raised to the power of n times t. So n is 12, which means we get 12 times 10. Okay, so let me change those values to 12 and 12 times 10, which is 120, and I'm getting 26,834.99. And once again, this is, the difference here may be negligible, but imagine you have millions of dollars in the bank, or a company has millions of dollars in the bank, then they're going to care very much about whether the interest is getting compounded daily or monthly. And then these two we will do in class. Now, sometimes interest gets compounded continuously, which means every single second the interest is getting compounded. When that happens, the formula is A equals to P times e to the RT power. And e we're going to talk more about later on. E is a natural number. It's an irrational number like pi. Pi is like 3.14159, keeps going forever. Same thing with e. E is a natural number, and the value of e is 2.718, 281, blah, 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 blah. So it's an irrational number that keeps going, but it does have a fixed value. On your calculator, you'll see an E button, so make sure you know how to find that. The formula for continuously compounded interest is A equals to P, the principal amount, times e to the r times t, where r is the interest rate, t is time. Here's an example. You deposit $6,000 at an account earning 8% interest compounded continuously. So we know to use this formula when we have this keyword that the interest is compounded continuously. How much will you have in the account after 5 years? Okay, so the amount in your account, oops, my screen keeps going back. The amount in your account, A, is going to be the initial amount, which is $6,000. And because it's compounded continuously, we have to use this formula, times E raised to the power of R times T. So 8%, that's 0.08 in decimal form. And T is 5 years, so that'll be to the 5th power. Now what I would do is I would first figure out what this exponent is. So, multiply, can't write a 5. Multiply 0.08 times 5 because it's just going to be more helpful and a little bit easier to have that done first. So that's going to be 0.4. So the amount in your account is given by the principal amount, which is 6,000 times e raised to the 0.4 power. Now you got to figure out how do you put this into your calculator. So find your e button and figure out how to raise e to the zero point 0.4 power. You can just go to YouTube, put in your calculator's model, and type in how to work with e, and you'll get some kind of tutorial. So I'm going to plug this in, and I'm going to get 6,000 times e raised to the zero point 0.4 power, and I'm getting 8950.95. But again, it's really important that you practice this so you know that you know how to use the calculator. Next example, the fox population in a certain region has a continuous growth rate of 5% per year. So notice that we're saying continuous growth rate, which automatically triggers that formula, P times e to the RT. It is estimated that the population in 2000 was 10,800. So first off, we want to find a function that models the population t years after 2000. And we're going to say 2000 is t equals to 0. So in the year 2000, our population was 10,800. So that's going to be the value of p. P is going to be the initial amount. Times, and because we have a continuous growth rate, it's going to be e raised to the power of r, which is 0.05. You multiply 5% by 100 to get 0.05. Just like over here, we take 8%, divide that by 100 to get 0.08. So we have 0.05. And then we want to just have a generic model, so I'm going to leave t for time. Okay, and that'll be the function that models the population after t years after 2000. Now, part B says use the function to estimate the population in 2008. So in 2008, how many years have passed since 2000? Well, t is going to be 2008 minus 2000, which is going to be 8 years. So our population is going to be 10,800 times e raised to the power of 0.05 times t, which is 8. Okay, so we have 10,800 times e raised to the power of 0.05 times 8, and that'll once again give you 0.4. And if you plug this into a calculator, you're going to get 16,100.70 or 111.70. And of course, we can't have 0.70 of a fox, so we're going to round this up to 16,112 foxes. Okay, so to break it down, always start with the initial population or initial amount, whatever it is, times e raised to the power of r times t, where r is the rate of growth or decay. All right. And then this problem should look kind of familiar. It was similar to the one we did before. So before we said that, this same, like similar values, but the growth rate is 5%. Here, the growth rate is continuous, and it's continuous growth rate of 5%, which is why we used a different formula. All right, that's it. Please come to class with questions.